Hey everyone, welcome to night 3 of authentication. So the material tonight is going to look a whole lot like what we saw on Thursday, where we're exploring the ways in which once a user is verified, we can make sure that they are able to see what they're authorized to see and that there's communication between the server and client. So what we learned about on Thursday was one technique of managing this, which is cookies and sessions. And tonight we're going to explore an alternative to accomplishing the same task with JSON web tokens. So without any further ado, let me share my screen. There will be some more questionable whiteboarding tonight, and we'll do a little review of sessions and cookies and then explore the differences between what we already saw on Thursday and what we'll explore tonight, which is web tokens. I don't want totally full screen. All right, so thank you for the compliments on my style. I feel like I've been a little grungy for you guys because I've been fighting a never-ending cold, but yeah, I think I put myself together tonight, so thanks for noticing. All right, let's do a little review from Thursday. So we have, once again, this kind of general model of the different systems we're working with. We have on the back end our server and our database, and on the front end, a couple different clients that might be interacting with these via a desktop and a cell phone that looks a little bit more like a cell phone this time. So to do a review, let's just walk through this whole auth process. So the very first thing we need is some set of credentials in the database. And we know that that's accomplished through a registration. So if the client performs a register function, they're going to send some sort of username and password combo here. And I know we've already talked about this multiple times, but little review. What should the server's first step be upon receiving a username and password via registration? What should the server always do first, or pretty darn near first, when it receives this username password combo? Hash, yes. I was thinking of you guys because I was working with a site this weekend that I did a password reset for a friend of mine, and it sent me the new passwords to his email, and I was like, no, don't do it. So that site was clearly not hashing. So anyways, we want to make sure that the first thing that happens when a password hits our server is that it is turned into a hash. So over here we have the password should become a hash. And while we're at it, we're going to talk a little bit about hashing functions again tonight. So remind me, what makes a hash so special? What is special about a hashing function versus good old-fashioned regular encryption? Why are hashes our favorite secure way of doing things when we can? It cannot be undone. So this is a one-way function. There's no way, there's other clever ways to decode a hash with things like lookup tables, but there's literally no way to straight up undo this function. Once we've done it, it is in hash form. So then we go to the database and we store the username and the hash, no passwords, in the database. So the username and hash is stored. Excuse me. And then, of course, what we hope would happen is that when we log in, whether it's from the same device or a different device, that as long as our password can be mapped to that same hash, that we receive a successful verification, and that there's some way of these devices to gain access to any restricted endpoints for a certain amount of time, right? That is the whole idea of verification, is that there should be some way for our client to continue to have access to everything they should have access to for a set amount of time. So let's do a little review of how to do this with sessions and cookies. I don't want to spend too much time on this, but a little review. So if we were working with sessions and cookies, Upon a successful registration or a successful login, what would happen? What happens on the back end upon a successful either login or registration? Yep, so whether it's being stored in the database or possibly in a data store like Redis, we'll say we're using Redis over here. I forget, does Redis have 1D or 2? I think it's just 1. I left a little room in case otherwise. All right, so over here, we want to keep track of our sessions. So this is on a successful login or a successful registration. A session is created here. And then what happens next? So the server creates a session. There's some sort of ID in here. And then what is sent back to the client? A cookie. So we would send back a cookie. And the cookie is encrypted, not hashed, because we want to be able to undo it. So the cookie is like an access pass. It's like a key fob. So if this if this client has a cookie, which would be specifically stored on a browser, the entire desktop could not have a cookie. It would be browser specific. But if this desktop has a cookie, and that cookie maps successfully to a session that's stored on the server, that means that any endpoint for a set amount of time, this client's going to be able to access it. We'll always send the cookie. And as long as the cookie is valid, if we tamper with the cookie, we're in trouble. If we delete the cookie, we're in trouble. If we try and move the cookie to a different device, or if the session expires. But as long as we have a valid cookie on the valid browser that matches a valid session, we should have access to all of our endpoints with that. So that is one way of managing this authentication authorization business, is to store a session over here and then to pass back and forth a cookie that maps to that. So before we talk about the alternative of using web tokens, what are some downsides of this approach? And we didn't talk too much about this on Thursday, so just throw out some ideas. What might be some downsides about using sessions and cookies? Memory. So there is this whole business of storing the sessions. We did talk a little bit about how you do want to set up ideally you'd want to set up a separate data store for this, which is an extra step. And if you're not handling cleanup properly, which is to say if you're not going through and actually wiping out the expired sessions, you can end up with a whole bunch of stuff that you're storing that isn't really valid and you don't need. The user has the option to approve cookies. That's a really good point. So recently, there's been a lot of legislation around cookies, and now the user has the option to approve them. So some users do not like cookies. And there's just, once again, the extra step of making sure that your user does approve and that there's built-in functionality on the front end to handle that. Any other thoughts on some downsides to this? The cookie is sent every time. That is true, but there's kind of no way around that. If you want access, you have to send something every time to have an access pass. So I don't know of any way of doing this that doesn't involve that, and we'll see that you have to do something similar with a web token. But still an interesting point. So I'm going to bring up one other downside to this that is actually one of the biggest downsides. And it's not totally obvious, and we didn't talk about it on Thursday. So one of the biggest downsides with having to store these sessions is that a lot of the times on bigger applications, there's going to be multiple servers. So you want to make sure that throughout different servers and different services, you might want one authentication system so that if you're, for example, a banking system might have their actual bank, and then they might have a related credit card partner that they work with. And then if you want to do, set up your 401k with them, they might have a related service. And it would be awfully nice if you could just be validated once and have access to all these services. Now, if you do keep your sessions in a separate data store, you can potentially connect multiple servers to one authentication system, but it still can become tricky. So one of the biggest downsides to the session cookie business is there's already this issue of session storage, but when you're dealing with a bigger application that might have many databases all kind of related around a similar idea, it creates additional complexity. So there are some potential issues with this approach, and we're going to see how web tokens, apart from the issue of sending the cookie every time, which will essentially be the same with web tokens, we're going to see how web tokens solve a lot of those problems and make our backend setup extremely simple. So, and one other thing that you guys threw out is that attackers can possibly read cookie data. It's true that these are encrypted, which means that they can't be read unless you have the encryption key. But unlike with hashes, there is the possibility that a hacker could get the encryption key and open this, which is not ideal. Even so, that's not a huge security risk because generally you don't want to be sending anything too secure in here anyways. But yeah, there can be an issue with someone getting a hold of the data in the cookie. But once again, that is kind of just part of the deal. Though with web tokens, actually, it's even easier to get in. But we'll get to that in a minute. So any questions about what we've seen so far? Any questions about sessions and cookies or this general authentication stuff before we move on to exploring a different model? What exactly is Redis? I don't want to spend too much time talking about that, but it's what's called a data store, which is a slightly more lightweight version of a database. So it's kind of semi-persistent. I haven't actually worked with Redis a ton myself, though I've worked on teams where someone else was working with Redis. So I don't have a lot of experience with it, but yeah, so it's something called a data store, and it would be similar to persistently stored data, but it's not as much upfront work as setting up an entire database. And in the real world, you would definitely want to use Redis over a full-on database, and you wouldn't want your sessions in the same database where you're storing all the rest of your resources. Yep, if someone else has worked a little more with Redis, feel free to share. So yeah, it allows you, that's a good description, it allows you to cache data. So rather than actually persistently storing it, you're just caching it. So it's a more short-term way of storing. It's kind of a medium-term way of storing data. All right, I'm going to knock out everything related to sessions and cookies so we can start talking about web tokens. Hold on. All right. So, oh wait, we have one more cookie on the loose. So everything else, our starting point is going to be the same with JSON web tokens, which is that we have a registration, we have logins, we want some way for the client to continue to be authorized once they've authenticated themselves. So the really cool thing about web tokens versus the cookie session system is that the server literally has to store one thing. So the server has a secret that they're storing. I'll put that right here. And when I say a secret, it's literally just a secret phrase. So I'll explain how this is possible in a minute, but once again, the server will store one secret phrase. That's the only thing the server has to keep track of. So just like the encryption key on the cookies, this would be something that's probably stored in an environment file or other way, there's different secret files you might store, but it's just one secret that the entire server or potentially multiple servers in a related system are using. So there's one secret phrase, and that is the only thing the server has to keep track of. So let's talk about how this even works. So we know that the user has registered or perhaps logged in with all of hashing. We've either added them to the database or on a login verified that their password matches the hash stored. And at that point, we want to give them some sort of access token. But now instead of a cookie, we're going to give them what's called a JSON web token or a JWT or a JOT. So what the server will do is generate something called a JWT and send it back. Now, in a moment, we're going to switch gears and talk about literally what goes into this JWT, but it's actually just an object. So it's going to be encrypted, but it's very easy to decode. So this is not something that you would want to store anything secretive in, but essentially this is just an object that's being sent back to the client. Now, this object will contain a little bit of metadata. It's going to probably contain the user ID of whoever verified themselves, potentially something like roles, whether it's admin, permissions, things like that. So this JWT will contain things like, and keep in mind, this is just an object, like a user ID or permissions or roles, but it should not contain anything sensitive because it's not even encrypted like a cookie. So just like a cookie, when the JOT hits the client, it's going to be stored and sent back with every single request. So to recap what we've said so far, the server is not creating any sessions. It's not tracking individual people who have been verified. There's just one object called a JOT that's being sent back, and a client can use it to access restricted endpoints. So if you guys are paying any attention, you're probably asking yourself right now, wait, how would this work? How would you, most of all, the question you should probably be asking yourself is, why can't the client just tamper with this thing, right? If this says I'm user ID number 72, why can't I just change that to 84 and then get access to user 84s? And that is the magic of a web token. And that's what we're going to be exploring in just a moment, is that even though this is just an object, there's this really clever thing that's been done to it that makes it untamperable. So the trick here is that as long as you haven't tampered with this web token, you can always use it to access stuff. And just like a cookie, it's going to have an expiration date. But that's the trick with a web token, is it will contain a little bit of metadata about you. So all the information you need for the server is stored here, whether it's the user ID or roles. But this thing is untamperable. So you can't go in and change it, or else the server will know. So I know that there's kind of a big black box right now in the explanation of this, which is, how is this untamperable? And we'll explore that in a minute. But so far, does anyone have any questions about web tokens and how they work? This is one that it's easy to overcomplicate, because for the most part, you can just think of it as an object that's being sent back and forth. So for example, if I hit an endpoint on the server to see all, if it was the social media app, to see all messages from user 72, as long as I have a JOT that says user ID 72 and hasn't been tampered with, then the server is going to say, yes, you have permission to see that. All right, well, let's jump on into, this is a useful little site that will let us explore more specifically what is in this object and why we can't get away with tampering with it. So when web tokens are sent, they're encoded. So they're going to look like these 3 crazy strings separated by dots. So I know that I said they were an object, but to get a little more specific, they're actually essentially 3 objects, or an object containing 3 objects. So we have 3 different JSON objects that are being sent in this form. But even though they're being sent encoded, they're really not secure. This is a really simple encoding that, for example, this website can decode any JOT, or any JOT that's using this specific algorithm. So don't think of these things as being secure. Unlike cookies, which have some level of security, there's no security in here. Everything that's being stored in this web token should be something that would be pretty harmless for anyone to get a hold of. So there are 3 different parts to this, and we're gonna kind of go in a weird order here and start by talking about the middle section of this token. So the middle section is called the payload, and that is the data. So any information that the server is going to need to figure out if this user has permission to see restricted endpoints needs to be stored in the middle here. So that might be sub, which stands for subject, is generally going to be a user ID of some sort. So the user ID might be stored here, perhaps the name of the user. As mentioned, sometimes roles or permissions might be included in here. And then usually there is a created at timestamp. So IAT stands for issued at, and perhaps an expiration date in here. So really the meat of the web token has to do with this middle section, the payload. So once again, with web tokens, I know I've said this a bunch already, but I'm going to keep saying it. With web tokens, there's no sessions being stored on the back end. Every bit of information that the server will need to figure out if you have permission to see an endpoint or not needs to be in this payload. So usually just by including a user ID and a username and perhaps some permissions, that should take care of everything that needs to be in the payload. So the payload is the stuff having to do with who this user is. So the next section is, the first section is the header. The header is just metadata. This says what algorithm is used to encode it and says that it's a web token. So the header is some metadata. Any questions about the purpose of the header or the payload, this first and second part of our web token? All right, so let's talk about the third part, the verify signature. So this is where it gets a little tricky and clever. As I mentioned when I was diagramming, the thing that makes web tokens special is that they are untamperable, right? Because I could just go in and say, actually, I'm this user ID instead. And then I would have permission to see everything that this user has permission to see. That would be really bad if we could just edit the payload, because the whole idea is that we should only have access to stuff if we've been verified as actually being the person in our payload. So this would be a very useless technology if the client could just go in and alter the payload. So the verify signature is what prevents the client from doing that. So what happens is that actually the information in the top, the information in the header, the information in the payload, and a secret key are all hashed together. So this last piece is, well, this is an encoded version of a hash, but this last piece is actually a hash. And the hash is generated by using a combination of the information up here in the payload and the header plus a secret. So let's take a minute to think about that. We know what hashes are. We know that they're these one-way functions that create unique keys. So in order to create the verify signature, we need to hash the payload data and the secret. So what would happen, and this is a little bit hard to wrap your mind around the first time you hear it, but what would happen? Can anyone infer why this is untamperable? What would happen on the server side if I tried to change my user ID or any of the information in the payload? What would go wrong when I, as the client, sent a tampered web token back to the server. So it wouldn't match. What wouldn't match? So I think you guys are on the right track, but get a little more specific. You guys are super close, but I think you get the general idea. But let's break it down. So what is going to happen when the server receives a web token is it's going to unencode it. It's going to take the header, take the payload, take the secret that only the server knows, and hash them all together. And then it will check to see if that hash matches the verify signature. So once again, the server is taking the header, the payload, and combining them. It's almost like a salt. So it's combining them with a secret phrase it has hidden in the server and then hashes them. And that hash should match this. But it will only match the verify signature if the payload and the header are exactly the same as how they started. So here's a question for you guys. If I wanted to tamper with the payload, why couldn't I just change the verify signature? So the whole issue is that if the verify signature is the same, but the payload has changed, we know they're not going to match. But why couldn't I, the client, just change the verify signature so that my tampered payload is believable now? Because I don't have the secret, exactly. So the only way to get a valid verify signature is with the secret. So there's no way to tamper with this thing. Well, you can tamper with it, it's just the server's gonna know. So the only way to truly fake a web token would be if you got that secret from the server. So there is still vulnerability here. If a hacker were able to get that secret from the server, then it would actually be extremely easy to tamper with a web token. But that's why you want to make sure that that one thing is well protected on the server side. So that's what's cool about a web token is while it's really easy to tamper with on the client side, it's also really easy for the server to know if it's been tampered with. So in that way, the server doesn't have to keep track of any data. All the data having to do with your user and your permission is stored in this payload. The server's one job is to check to make sure that the stuff in the payload is actually accurate and has not been tampered with. And as long as the new hash that the server generates upon receiving this matches the verify signature, then it will give you access to whatever endpoints this user with this ID and this role should have. And of course, also checking for expiration if that's been included. So that's the theory behind web tokens. Any questions about how this works before we jump in and start to actually explore implementing a backend using this technology? Where is the verified hash stored? So the verified hash is actually, well, the original hash is stored directly on the web token. So this last part of the web token is the hash. Now, when the server is checking to make sure it hasn't been tampered with, that hash, that second hash that's generated won't be stored anywhere. Each time the server receives this web token, it will check. So this web token will come in, the server will grab the header, the payload, and the secret, generate a new hash, check to see if it matches the third part of the token, and then it won't store anything. It'll just move on because every time it receives one, it rehashes it and goes through that process. Yes, the secret should never be hard-coded. So we'll talk about, when we actually go into the code, we'll talk about what, well, it can be hard-coded into an environment variable file or a secret file, which would be included in a get ignore. So it might be actually coded in somewhere on your code base, but on your personal copy of the code base, but it would never be hard coded in something that's going to be pushed up to GitHub. Usually there's going to be like a development version that's hard coded in, but then the actual production secret would be stored as an environment variable. All right, I have one more question for you guys to test your understanding of the theory behind this. So what should happen on a logout? This might take a second to think about. If we're implementing a auth system with web tokens, what would happen on a logout? Delete the token. Yep, so let's get specific. Who is deleting the token? The client, yep. So actually nothing happens on the server side. We won't even write a logout function tonight because it's boring. Nothing happens on the server side on a logout because the logout, the only thing the server is doing is storing a secret, and that it doesn't really care who is logged in and out. So it is actually up to the client to enforce a logout and destroy the web token. And keep in mind when I say the client, I don't mean that the user actually has to go in and remove it from local storage. The web application, the JavaScript side of the web application would handle that. Yep, so that's React's job. All right, let's go ahead and work with some code here. So if anyone does not have the guided project for tonight yet, I will post that in Slack. And here is my version of it. So this is going to look really similar to what we've been working with in the sprint so far. We're just kind of working with a register login and a user's endpoint. So let's take a look at what we have so far. I think All right. So we have our server code. And we see that there are some auth endpoints and some user endpoints. So let's go poking around in our auth router. We have a registration and a login, as expected. And in users, we have a user router that's restricted, and it's just finding all users. And then finally, we have this restricted middleware. And we can see right now that this is kind of the night one version of the middleware. This is the way we definitely don't want to be authorizing an endpoint. We are actually rechecking the username and password, which for one, we don't want to do. They should already have an access pass of some sort. And we certainly don't want these via headers. So we know we're going to be refactoring this middleware. All right, so let's start at the beginning on registration. We're already using bcrypt. That's a good sign. So what do we need to add here? We're now thinking about implementing this with web tokens. So what would we need to build in here? All right, we definitely want a web token. At what point in this function would we want a web token? So we're going to want to use it on register and login as soon as they register successfully. So down here, we see that the user has been saved. And you already kind of got ahead of me and mentioned that there should probably be a similar thing happening in login. So at the point that we've successfully compared these guys and figured out that this is a valid user, we would want a web token generated here as well. So we know that this logic should be pretty much identical. And when we have the same thing happening in two different places, that's a good opportunity to use a helper function of some sort. So we're going to want some sort of, let's just put this down here, some sort of generate token function that we can use in case of both a successful registration and a successful login. So what type of stuff needs, from what you guys know about web tokens, what kind of stuff needs to happen down here? What would happen in this generate token session, or in this generate token function? And you don't need to know the exact code, but just kind of on a pseudocode high level. We need a header, body, and verify signature. The header is usually pretty straightforward. What goes into the body? What kind of stuff might we want to include in the body? Or sorry, the payload. We probably want to put the username in, the ID, maybe. I think that this, we actually have some sort of roles built into our, built into this database. So some roles, maybe an expiration date, stuff like that. And then now keep in mind, we won't put the hash into the payload because the hash will be generated with the payload. So that would kind of create a snake eating its own tail type situation. So that's why in the verify signature, we would actually create a hash. So in order to create this hash, we need a secret somewhere. So just looking at this right now, I'm seeing that, first of all, this generate token function should probably take in a user because there's some metadata about our user that we're going to want to store in here. So we should be passing in a user object when we generate the token so we can actually fill our payload with meaningful information. The next thing we're going to need is we need a secret somewhere. So let's go ahead and take care of that. Now here we have, let me see something interesting. So let's go ahead and, do you guys want to do the secret the cheating way, or do you guys want to actually go through and create an environment variable for it? What do you think? How are you feeling? All right, let's do it the proper way. So as a no cheating allowed. Fine, I wanted to cheat, but you guys, all right. So we did this, I know we did this once or twice before, but let's go ahead and, I think we did this once or twice before. Have we worked with environment variables yet? Cool, all right, that's what I thought. So we're gonna need to install .env. And a little reminder, which is that this .env library, oops, we need an env in there. This .env library essentially just pulls information from an env file and puts it on process.env. So yeah, it was on the deployment night that we set this up. So a little refresher, but this is really easy to use. All you have to do is set this up at the very beginning of your server code. So that's going to go at the very top of server.js. So this means that we can now create a .env file. Now we always want to make sure that .env is included in our getignore, which it is, so that's good. So the idea here is that though you might have this secret locally, it's never going to get pushed to GitHub. So we could say secret equals so now if we go into, I'll just kind of randomly go in here, and we console.log process.env dot, let's start our server. Oops. So we see that it's being logged. So because we have set this up, we actually have access on process.env to the secret. The idea, of course, being that this would just be the stand-in secret for development, but the actual production secret we could store securely when this app is deployed. All right, so I'll give you guys a second to catch up on that. And if you have any questions about environment variables or having any problems getting this set up, just let me know. Sure. Let's. Yeah, it's pretty easy to set up. For a second secret, so if you had something else, like let's say some sort of encryption key, yeah, you would just do a new line. There's no need for semicolon or anything like that. No commas. This is also where you generally put, since we haven't this set up, we might as well put our port in here. And then we could go into just a little review. We could go into our, where is my index.js? Oh, cool. So it's already built in to use that. So instead of using the default, if we restart our server, it's going to use that port that I just put in. So now it's on 3000. So a little question for you guys. Why is it that my server did not automatically restart with the new port? Why did I have to, because normally Nodamon's pretty good about that, but why did I actually have to kill the server and manually restart it to see our new port? Yep, so Nodamon ignores get ignored files. So making a change to .env won't actually restart our server because it is get ignored. All right, I think we are ready to get back to our generate token function. So most of the hard work here, we're going to, of course, let a library take care of for us. So this is, wait, oh no, I don't have the documentation. So this is the library we are going to use. And I actually like this library better than the one we used for sessions, because that library does so much for you that you almost don't even think about what's going on. And while that's kind of convenient if you understand the theory, it's almost a little detrimental when you're first learning this stuff. The JSON Web Token library, it takes care of the hard stuff for you, but you have to do a little bit more work to get it off the ground. So let's go ahead and install that. While that's installing, we'll just poke around the docs a little bit. Speaking of cookies, so we see that we're going to have to set up some options. If we want to change the algorithm we're using to encode, we can do that, but we'll use the default. We can set up an expiration date, and they have their own kind of system of how you can specify the expiration on this. Just different stuff we might do. There's a sign function we're going to use. All right, let's go back here and actually take care of this. So we need to manually specify our payload when we're working with this library. So generally, our user ID is going to be called sub. That's just kind of standard. So we can pull that from here. We could do username. Let me double check. I'm going to go actually into our database here with my brain just stopped working for a second. What is the name of our database visualizer? Too many things. SQLite Studio. Yes, now I remember. All right, SQLite Studio. Let's open it up and go into our guided project. Database, open that up. All right, so it looks like they actually do not have any roles stored in here, so we won't worry about that. So this is a totally valid payload. We just have our user ID and our username. This should give the server all the information it needs to know if a user is allowed to see an endpoint or not. The next thing we're going to have to set up here is some options. So we're fine using the default encoding algorithm, but I do want to make sure that our web tokens are going to expire. So we'll throw in an expires in and a 1D. Once again, this syntax for expiration is specific to this library. So if you want to see other ways, you can put in different options here. So you can type out days or use D or hours, so on and so forth. All right, so as far as the header and the verify signature go, we're pretty much taken care of. So the header would be different, might change if we put in it. The options object is kind of all-purpose for metadata, but the verify signature will be automatically generated for us. So there's the sign function. It's not asynchronous, and it expects the payload and the secret. So we definitely need to pass in a secret in order to make sure that our verify signature can be created. So where are we getting our secret from again? What would I put in as the second argument? It's coming from the environment file, but what specifically would I put in here to access that variable? Yep, process.env. As a reminder, process.env is a universal node thing. So this is always in all node applications, this is where environment variables are stored. And this is just what we named this particular variable. So these are the two critical pieces that you need to pass into the sign function. And then finally, we can pass in our options as the third parameter to make sure our expiration date gets in there. So there we go. Let me give you guys a second to catch up on this generate token function. And we'll talk about, if you have any questions, I can answer that, and then we'll go ahead and implement it in a minute. Oh, yep, I think, good catch. I forgot to require our library. So yep, I used the library, but never actually required it. Any questions about what I've done here? All right, I think it's about time for our break. So let's go ahead and take 5 minutes, and then we will implement this web token stuff. All right, I'll see you guys in 5. So during the break, there was a question in Slack about two-factor authentication, which we're not going to be implementing here, but I thought I'd just say something in the video about it, /live for anyone who doesn't want to read the paragraph I wrote in Slack. So two-factor authentication is something that's used. So this would be one-factor authentication. This is kind of standard, which is just we make sure your password and your username matches. But often there's two-factor, which is usually maybe the first time you log in on a new device, it's going to be used, or if you log in and you haven't logged in a while, it's used, or in some cases, for example, in my old job, I worked with medical data, and I had to use two-factor authentication to log in every single time because it was a highly secure system. So all that means is that it's usually, they want to make sure that you're you, and the way they do that is generally with your phone. So it's like when Google sends you a code and then you have to enter it in. Or when the really advanced way to do it is you actually have an application that has a new code that's generated every 30 seconds and you have to enter that in. That's how I did it at work. Or they send you an email with a code. And so that's not going to replace this. It's just an extra step on top of this to make sure that the person behind the computer actually is holding the device that's stored with your account or has access to the email account. And I imagine if you wanted to code that in, it would be very simple. You just need to generate a code and send it to a device. The only tricky part about implementing that would be putting in the logic of making, checking if someone is on a new device or if they haven't logged in a while. So I've never actually written the code for that system, but you can kind of imagine how it would work, and you could certainly see how it would add another layer of security to all this. Yeah, and I no doubt there is many third-party libraries that would just take care of two-factor for you. One of you guys suggested Google's. All right, so let's go ahead and put this back in. Or put this in our code. So we have this generate token helper, which takes in a user and using a little bit of information from that user, and our secret is going to generate a token. So let's scroll on back up to registration. So at this point, we would want and we have to pass in our saved user, because keep in mind, this user is just the info from the rec.body, so it doesn't actually have an ID. So we'll pass in the saved one, we get a token, and then we always need to make sure that we're sending it back. So this was a shortcut we were able to take with the session library, because that just automatically attached the session. In this, we need to manually send back our token. So I'm just going to make sure that instead of just our user, we're also sending back a token. As well, basically the same logic should happen down here. So this time our user is called user. This is the actual database user. And then instead of this welcome message, or in addition to this welcome message, we're going to send back our token. So at this point, on a successful registration and a successful login, we expect to see a token being sent back in the response. So let's jump on over into Insomnia, and let me get rid of that console log. It's in server. So let's jump on over into Insomnia and make sure that we're seeing something valid so far. That's not Insomnia. This is Insomnia. All right, let's start with a post request to API auth register. No, wrong port. All right, so we see that we're getting our token back. Let me grab this thing. So if we wanted to find out what is actually stored in this token, what would we do? What could we do? Without even accessing the server code at all, just as a client, we want to check out what's going on here. Yeah, let's go back to that nifty site. Little reminder, these things are not secure. They can be easily decoded. And sure enough, we already see that my user ID, my username, a timestamp for when this was created, and a timestamp for when it expires. So we can very easily decode this thing. But that's good because it seems to contain the information we wanted it to. All right, let's make sure that the login is working as well. That looks like the same token, but just to be sure. Yep, same token. And just, we always want to make sure that we can break something. So let's change the password. Let's try invalid username. Cool. So all of that seems to be in working order. Now notice that when we send this token, it's automatically encoded for us. But just to give us an idea, let's go ahead and do a quick console log in here. I'll actually do it in login to see what this token object looks like. It's always nice to know what our library is giving us. I'll hit that login endpoint one more time. So the thing that it's returning is actually this fully encrypted thing. So keep that in mind, because if we want to, on the server side, poke around in here, we're going to need a decoded version of this. And yes, there is some functionality built into our library that will help with that. All right, so what do we have left to do? Our post and our two posts to register and log in are both looking pretty good. What do we have left to do so that this full auth system is working properly? So we don't actually need to save the token because that is the client's responsibility. So then once again, that is the beautiful thing about tokens, especially from the backend perspective, is our workload is pretty low. But we do, on any restricted endpoints, we are going to need to verify this. So we're going to have to go over to this restricted middleware file and change this up. So instead of, I'm just going to wipe all of this code clean and start from scratch. So let's start by pseudocoding. What should happen in this endpoint? Well, I'll give you a little hint, which is, I wouldn't expect you to know off the cuff, which is that generally speaking, the place you would expect to see your token is in rec.headers.authorization. That's kind of a standard header that you'd use for web tokens. So we know where to find the token, but now let's go ahead and pseudocode out what should happen in this restricted middleware. Keep in mind, this is the middleware that any request to an authorized endpoint needs to pass through. Yeah, first we want to even see if there is a token. Assuming there is one, then what would we want to do? Check if it is valid. So we're gonna have to, what that literally means is rehash the header plus payload plus secret and see if it matches our verify signature. So this step actually is going to be taken care of by our library, but keep in mind that that is what is happening behind the scene. We're taking the first two parts of our token plus our secret, hashing them, and making sure that they match the third part of our token. And that will guarantee that neither of these have been tampered with, because there's no way they could match unless somehow a hacker had access to our secret. And then potentially, you might imagine, you know, extracting something like the user ID or username or roles, because in a real world example, usually endpoints are going to be user specific. But in this case, we get to kind of skip this step because all we're really checking to see is if you are a valid user or not. So let's go ahead and implement that. So we'll start with if token. And if not, we can send back all right. So the big step here is checking our token, making sure that it has not been tampered with. And as mentioned, our library will take care of that for us. So this time I will remember to require the library. And then we're going to use a function called verify. Now verify takes in, first of all, the token, second of all, our secret, which of course it will need in order to generate the new hash. And then finally, we'll do a callback with an error and the decoded token. So if we ever wanted to decode our token, this is one way we could do it. Though mostly this is meant to actually, the main thing that's happening here is we're checking to make sure that our verify signature is valid. Okay. So if something has gone wrong here, we'll get an error. Otherwise, we know that our token is valid. This also will check to make sure our token is not expired. So we can play with a few different cases here once we're done writing this code. So if there's an error, we might send back I'm going to console log this error because I think we're going to want to look at it later. All right, otherwise we would want to theoretically just run next. But the problem with running next is, as I mentioned, this for what we're doing today, that will work. But we want to think beyond what we're doing. Once again, we want to think about the fact that often the restriction might be specific to information about the user, such as their ID or their roles. So it would be nice if we could actually pass along the decoded token so that whatever endpoint we're working with would have access to that information. So the easiest way to do that is to actually just attach it onto the rec object. And I think we'll have enough time to play with something with the role scenario. So for right now, we're not really going to use this decoded token, but since we decoded it, we might as well put it on rec so that our endpoint has access to it if it needs it. So this should be good to go. Let's go ahead and check it out over here in Insomnia. So a little gotcha here, make sure that you copy this token without the quotes. It will not be read properly if we don't have the quotes. So let's go ahead and add an authorization header, put our token on here, and then hit this API users endpoint. What's going on? Oh, that semicolon does not belong. Server looks good. Come on. There we go. So we're authorized to see our endpoint. So let me give you guys a minute to catch up on this code, ask any questions, and then, as always, we're gonna try and break this every way we can, because I'm not convinced it works until I'm convinced I can break it. All right, so we want to see this fail. We want to see some situations in which our authorization does not work. So what are a few different ways that, a few different things that we could do that might cause this to not work? Or we would hope that it would cause it to not work. What are some situations in which our web token should not? Yeah, if we tamper. So let's go in. I mean, if we just literally went in and deleted a couple keys, that should break it. But let's get a little more sophisticated than that. Let's think about the scenario that would really happen, which is that someone goes in, they decode the token, and they say, I actually want to pretend to be user number 2, Steve. So, or they want to extend the expiration date. Let's make this expire a few days later. So we're going in and we're tampering. But of course, we know this isn't going to work, because even though we've tampered with the payload, the verify signature is the same. So if we go over here and use this new, so this is actually a valid token, whereas when I just deleted a couple characters, that wouldn't even decode properly. But this is a real token. It's just not the one the server gave me. So when we send this, we get not verified. And actually, let's look at our error messages down here. So we're getting invalid signature. Wait, that is, yeah. Interesting. Yep. So the first thing we got was invalid token. So when I actually just deleted some stuff, we got invalid token, right? Because it wasn't even a real token. But then on the second time, we got the message invalid signature. So that's pretty good. We definitely want our server to say no to tampered with tokens. The last thing we might do is play with expiration. So if we, let me double check how to do this in our library. So we can store this in milliseconds. So if we went ahead and changed our option here so that it expired in 100 milliseconds, we feel pretty confident that by the time we send it back, it's going to be expired. So let's try this one. I'm going to start by, let's create a new user. So we created a new user and we got a token. But this token has a very short lifespan. So at this point, it's already expired. So let's go ahead and do a GET request to users. In our headers, we will put in this new token. Come on. And then send. And sure enough, this time we got the message that our token is expired. So I'll put this back to 1 day. But I think we've checked the kind of the 3 cases we'd expect to see where the token is completely invalid, it's been tampered with, or it's expired. Yep, so the tokens are not being stored anywhere server side. Each individual client is responsible for storing their token on the client side, but the server is not storing the token. All it's doing is every time it comes in, it decodes it and makes sure that it's valid. Yeah, it really does save a lot of space and a lot of hassle on the server side. Great question. I always wait for this one to come up. Can you just steal my token? Yes. So that is one of the downsides to tokens, is that if you go into my browser and take my token, then you have just become me. So that is a good reason to not let people use your computer if you don't know and trust them and think they might have some knowledge of this stuff. But it's also a really good reason for tokens to expire. So that is one of the big downsides of tokens over cookies, is that cookies are browser specific, whereas tokens are not. There's really no way to set that up with the system. So that is a definite downside to tokens, is that if you can get into someone else's browser and get their token, then you are functionally them. Another really good reason for two-factor authentication. So yeah, that's kind of the way around that. Is I would say if you want to, if you're using web tokens and you want to secure, you should have some sort of system set up where there's a two-factor authentication system that triggers on a new device or on an infrequent login, because that will catch that. Not because it won't be able to tell the token is invalid because it is a valid token, but it will be able to tell that that person is not you if they don't have access to your phone or your email. What is more commonly used? They're both definitely used frequently. This is where I am not enough of an auth expert to really understand why people use one or the other in different cases beyond the general stuff we've talked about. But my understanding is that JOTs are preferred, but cookies are still quite frequently used. Yeah, that's a good point, that we're probably going to see less and less cookies given the legislation that's been passed with them. All right, we've got a bit more time, so I think we should go ahead and play with something with roles. Could a security system use both? It wouldn't really make sense to use both cookies and web tokens. They're doing something very similar. So in two-factor, it's generally not the two systems of auth, it's two approaches. So you'd have JOTS and a phone verification, or cookies and a phone verification. I've never heard of them being used together, but it's not impossible that that's a thing that is sometimes done. I've just never heard of it. All right, so let's go ahead and play with this roles thing. So we're gonna have to do a quick migrate. Well, do we want to migrate or do we want to just fake it? Let's do it the good way. Let's do it right. So it'll give you guys a little bit of database practice. So let's create a new migration. All right, so connects, migrate, make, add roles. All right, so over here in database. So all we're trying to do here is add a column. So what we'll do is start schema table, users, I actually haven't done this in a minute. Let me double check the syntax on this one. So yep, we'll want, perfect. So just the same syntax of string, role. And we won't make this required because then we'd have to go back and change our other data. Okay, so we have a new column called role, and then down here, a little reminder, if any of you guys have connected in SQLite Studio, make sure you disconnect from the database before we run this, because there can be some issues. So we're updating our table here. Connects, migrate, latest. And then I'm going to go in, and if you guys aren't connected in SQLite Studio, that's fine. But let's, I thought I disconnected. Oh wait, that is a different, oh dear, what did I do? Well, I think all we have to do is refresh. Oh, wait. Here we go. So we have the role. So that's good. We've got a role column in our database now. I think I hear something in my attic, which is really concerning. I might have to call an exterminator tomorrow. Anyways, that's a little distracting, but I will put that aside so we can finish our lesson. I wonder what it is. I don't think it's a monsoon demon. It definitely has little skittering claws, and I'm pretty sure monsoon demons are more ethereal and do not have claws. All right. So let's go ahead and, well, just for fun, let's create a couple new users in our database that have some roles. So maybe our role is user and admin. So post to registration. We're just going to keep everyone having the same password. Student. Do we already have a, oh wait, log. It's, what is it? Register. Thank you. Let's make Mark an admin. And the monsoon demon apparently has admin privileges. All right, so we have a couple admins in our system, a couple people who are missing roles from before, but so let's think about it this way. If our, let me go back to our user router. So here's the functionality I want to see. If the user is an admin, they can see all users. If the user isn't an admin, they can only see themselves. So this is a little tricky. I'm gonna leave this one up to you, but I wanna make sure that everyone has their database all set up. So before we start on this, is anyone having issues with their database set up? Does anyone need a minute more to get this new migration in place before we move on to altering this endpoint? All right, so I'm going to give you guys 5 minutes to work on this. Instead of just sending a master list of users, I want, if the user is an admin, they see the master list, otherwise they only see themselves. So I'll give you guys 5 minutes and check in on Slack and see how you're doing with this one. All right, good luck. just posted a poll in Slack. So keep me updated on your progress. This one is a little tricky, so if we need more than 5 minutes, that's totally fine. All right, keep me updated on your progress. I think this is maybe more like an 8-minute or 10-minute challenge. So I'm going to add some time to the timer, but definitely keep me updated. All right, most of you guys have it or haven't voted. Let's go ahead and work on the solution together. Now, as I'm sure you guys discovered working on this, this is a little tricky and requires you going into a few different places in the code base to get into effect. So the first thing we need to know here is, what is the role of the user? Now, fortunately, as a little reminder, if we go back to our middleware, we stored the decoded token on our rec object, so we can actually see it. So the first thing I would do if I were working on this is actually console log that token to see what it looks like. Decoded token. All right, so let me hit this endpoint with a valid token so that we can we'll hit it with the monsoon daemon. Right, and do a GET request to users. So of course, right now we're seeing the master list because that's what we've got. Okay, so we see that we do have the decoded token is essentially just our payload. That's good, but this would be the moment that we realize, wait a minute, we need information about our roles on our token if this is going to work. So we have to take a step back and go back over to our auth router and back to this generate token function. So back here, we put in our subject and our username, but there were no roles at this point. So let's go ahead and change this and add role user.role. Now we will have to generate a new token because the old tokens don't include this role. So we'll go back to login. Sorry, auth login. And log in for our monsoon daemon. Now, if we take a look at this token, I'll just go over here. We can see that it has a role. So that's already a good step. We now actually are including information about our roles on our tokens. So with that in mind, we can jump back on over to our user model, or sorry, our user router, and think about doing something conditional based on the role. So we could say if rec dot, what was it again? Decoded token. If rec dot decoded token dot role equals admin, then we can do this. Otherwise, we just want them to find ourselves. Yeah, good call. Let's go ahead and just pull off the role at the top because we are going to need the ID in a moment. So I like that. We're going to destructure this thing. And then down here, we want to just get our single user. So that brings us over here to our user model. Luckily, we do have a find by ID function here, so we can use it. So otherwise, users.find by ID. Yep. Oh, right. Oh, we'll call this sub. And then we can, and otherwise, let's put that status in there. All right, let's catch back up on everything we did. So having put the role on our token, we now have access to the role and to our ID. And then we can check if the role is admin. Otherwise, if it is, send back a master list of users. Otherwise, use find by ID and just send back our single user in question. So let's go ahead and jump back over to Insomnia and see if it worked. So we have this token for our Monsoon daemon, who is in fact an admin. So let's start with him. I can't remember if this is correct or not, but let's put it in. So we send this, and we do, in fact, see a master list of users. Now let's go back to, let's get a token for our very first user who doesn't even have a role. It's interesting that we're not getting any role data back here. I wonder why that is. All right, well, let's. I don't know why we're selecting password. I'm going to change password to role because really we should not be sending back a list of passwords to anyone. Oops, let's try that again. Cool. So we see we have 2 admins, a student, and a couple users without any roles. So let's do a quick login. On a non-admin. We've got that token. Now this would be different from the tokens that I was getting for this user before, because now the token includes a role. So we can put that token in there, go back to get our users, and we see that I got back that single user, but I did not get back the master list. All right. So any questions on this last piece that we put in? This is a little bit more like what you would expect to see in an actual application, is that your access to endpoints is going to be conditional on specific things to your user account, rather than you just get to see everything if you even have a login. Well, that's all I've got for you guys tonight. So let me go ahead and share with you the challenge for tonight. And then if you have any final questions at the end, I can cover those. So here is our challenge. So this one is very similar to what you've been working on, except you get an opportunity to practice some of your database and server basics. So if you look, this is one of those, there's almost nothing here. So you have to start from scratch, which is good because it's easy to forget all the other stuff you've learned. So you'll have to be implementing a full server with database, with migrations and all that. Username, password, and department. So this is going to be similar to what we did with roles. There is no need to create a separate departments table. That's probably what you would do in a real application, but the point of this exercise is not to practice foreign keys, it's to practice JOTs, so I would just put in the department. And then implement these 3 endpoints. So you're going to get a lot of opportunity to choose your design, choose what you want separated where, what routers you want, what middleware you want. So above just doing a little review of what you know from past sprints and implementing JOTs, definitely think about clean code and how to organize this stuff, because that's a really good skill to practice as well. And then finally, for your stretch problem, you're going to actually do some conditional behavior based on the department. So that's what we've got for you guys. Any final questions about JOTs or about this challenge or anything else? a refresher on implemented server stuff with Create React App. I think that would be a good topic for the actual Q&A. Because I just think that would take too much time to cover right now. So on that note, I do want to have a Q&A either tomorrow or Thursday. So I'm going to put out a poll for that. And if you want, I can definitely cover how to integrate the Create React app with server code. Recommended using Monsoon Demon as a username. I think that's a good idea. And if you guys are really eager for the Create React app stuff and you want to do your Q&A Thursday, I could just create a separate supplementary video for that. I think that's totally reasonable thing to request. So I will, unless you guys cannot wait, I will do a poll to see if the Q&A is going to be tomorrow or Thursday. If you choose Thursday, I will create tomorrow a supplementary video on that, so you guys can just review that. All right. Well, I will, right after we're done here, I'll post that poll about the Q&A date and time. So keep an eye out for that. And otherwise, good luck with this, and I will see you soon. All right, have a great night.